In this video, we will talk about multiple linear regression using analysis of variance or ANOVA approach. So we know multiple linear regression means there are more than two independent variables in linear regression to estimate or predict one response variable y. And there are several notations used in multiple linear regression, which is the same as in a simple linear regression for separating the error terms in the module. So this is the basic equation called SST equals SSR plus SSE. This is equal. And this part called SST, which is the sum of the squares of the difference between y value and the mean of y value. So this is the variance, odd variance of y. And this part, SSR, this part equals y hat. Y hat is the value on the regression line. So this is the fitted value of y. So sum of odd squares of the difference between fitted value and the mean value. So this is the model's power to capture the variance variation of y value. And this part is error terms sum square called SSE, which is the sum of the squares of the difference between observed y value and the fitted y value. So this part is error term, which is the model cannot estimate. So if this part is very large compared to this part, so if SSE very large compared to SSR, then which means the model is very little power to capture the variance of y. So we hope in ANOVA or analysis of variance approach, we hope this part as large as possible. So in this approach, there is H0, a null hypothesis says beta 1, beta 2, beta 3 until beta k all are 0. So which means the model is nothing, just a constant term. So if this is true, then SSR, SSE has degrees of freedom, and we divide SSR and SSE with their corresponding degrees of freedom. So this is called mean SSR and mean SSE. And under this assumption, these two parts follows chi-square distribution, SSR and SSE. So the division of two chi-square distributed random variable with their corresponding degrees of freedom follows an F distributed random variable. So analysis of variance approach using F test. So this part is the division of these two parts, and these two parts follows chi-square distribution. So which means the division is a F statistic follows F distribution. So after we have tested this F test, this is an up-tailed test, which means a one-tailed test. So if this test larger than the critical value, or which means the p-value is less than 0.05, then we will reject H0. So reject H0 implies that the regression equation differs from constant. So which means if the test is significant, we get the conclusion that not all beta coefficients are 0, which means at least one regressor variable is important to predict the response variable.